So again, welcome to today's webinar. Today we'll be talking about all things spatial indexes and specifically about how you can reduce costs with spatial indexes and use them to analyze very, very large data sets. So today with me is Helen McKenzie, Geospatial Advocate at CARTO.
Hi. Thanks everyone so much for coming, and thanks for that, Daria. I'm a Geospatial Advocate at CARTO, which we often say my actual job description is being CARTO's hype person. So my job is to get people super excited about geospatial data and analysis, which is obviously the most fun job in the world. If you've been to any of my webinars or events before, and I see quite a few familiar names in the attendee list, so hi, great to see some of you again. You'll know that I think spatial indexes are one of the best things to happen to geospatial data in the last year. So I'm really excited to be talking to you about this today.
Awesome, thanks Helen. And my name is Daria Kolarczyk. I'm the head of demand generation here at CARTO, and I'll be moderating today's webinar. Awesome. So Helen, back to you.
Awesome, thank you. So you're going to be hearing from me for the first sort of 20-25 minutes of this webinar. I'll be talking you through all sort of things technical spatial indexes. We'll be running through a practical demo, and the last 10-15 minutes we'll be going back to Daria, and she'll be talking about how organizations are implementing spatial indexes. So you'll see how businesses are really benefiting from these. So in those 45 minutes, hopefully you will take away these three things. So you will have learned what spatial indexes are and why you should be using them. And I'm really pleased to hear the results of those polls, because I think those numbers, that's exactly how we've pitched this talk. So hopefully there'll be something in here for everyone. You'll also learn how to get started with spatial index practically, so how you can actually start to use them in your analysis. And then finally, how organizations are leveraging the power of spatial indexes for big data analysis. So let's kick things off. Why are spatial indexes? But more importantly, why should you care what spatial indexes are? So at the most basic level, the most basic definition is spatial indexes are basically global grid systems. Now, spatial indexes actually have a lot of different names. You might hear them referred to different things. So if you hear the phrase global hierarchical grid system, that's the same thing, but it's just not quite as catchy, and a lot of people are calling them spatial indexes. So what's really interesting about these is they're multi-resolution. So you can have a grid that is like 1 meter by 1 meter, right up to a grid that is 100 kilometers by 100 kilometers, and they're hierarchical, so they fit together, so they match to each other, which makes them really powerful for multi-scale analysis. And there are lots of different types of spatial indexes, which we'll go into later. And what's really important about them as well is if you work with spatial data a lot, you might create grid systems, quite often maybe with something like QGIS or ArcGIS, and they're just sort of arbitrary grids. But the great thing about these is they are defined grid systems. So if you're using a spatial index, your partner or colleague might be using the same spatial index, you can really easily share data, which is a great benefit of them. So what are they actually for? What do people use spatial indexes for? Well, typically they use them as support geographies. And by support geographies, we mean that people will aggregate lots of different data sources. So it might be data from the census, it might be data from a transport department, lots of different things, just to one support geography, that spatial index, and use that as a framework for all of their analysis. And that's really, really helpful, because it means it can speed up your processing, save you loads of storage costs, and unlock new analytical capabilities. And we'll talk about how right now. So what the big deal is about spatial indexes and how they're different is they're basically geolocated in a different way to traditional spatial data. So if you look at the column on the left here, is a traditional way that a geometry is described. So this might be familiar to a lot of you. This is actually a census tract, I think, somewhere in New York. And you can see we've got loads of different coordinate pairs, so loads of different latitude and longitude pairs that describe every vertex in that census tract. And this is actually just about 1/10 of the description of one census tract. And this is really, really long. There's loads and loads of data just in this one description, which makes it really big, really heavy to store, and really slow to analyze. Spatial indexes, on the other hand, are georeferenced, so placed on the Earth, just by a short reference string. So there's an example here, I think it's about 14 characters long. And this one reference string will say where that grid cell is placed on the Earth and the size of it. That's it. It's so much smaller, and this is really the magic of it. It's that simple. It makes it really, really small to store, really quick to analyze, and it just speeds up what you're doing so much. I cannot stress enough. So in practice, this is what it looks like. We've run all sorts of tests with spatial indexes and looked at some of the savings you can expect to make the spatial indexes. So we estimate that you can save up to 98% of your processing time can be saved when you're using spatial indexes compared to traditional geometry. So that's 98% of your time that you can now be doing your analysis or creating your visualizations and really doing more impactful work than watching sort of a slow progress bar rotating on your screen. Similarly, we estimate that you can save on your cloud data warehouse bill by about 85%, and that's because this data is just so much smaller that any cost that you're incurring through storing data is going to be so much less. And then finally, a spatial join, if you're familiar with spatial joins, it's basically about taking data from one geography, maybe a county, and aggregating it to another geography. Maybe it's like a bespoke study area. So it's a really, really common type of spatial analysis and something that is really your bread and butter as a spatial data scientist or analyst. And we estimate that you're saving about 99% of time in that processing, which is amazing. So before I move on to the different types of spatial indexes and we see them in action, I just want to talk a little bit about the benefits of regular grid geometries regular grids in general. So there's sort of three main shapes that you can use to create a regular grid. You can create them with hexagons, squares, and triangles. And I'll talk a little bit more about the different types in a second. But most raw data comes in an irregular geometry form. So if you think about things like a census block, or here in the UK, we have output areas. They're very irregular shaped. We've seen earlier they've got lots of vertexes, and they're different sizes as well as shapes. And normally these sizes are dictated by population density. So you will have really, really big areas where in the countryside where there's a lower population density, and really, really small areas in urban areas where there's a higher population density. The reason for this is statistical bodies like to have the same-ish number of people living in every region, which has makes plenty of sense, but it also means that when you turn to mapping, this can be really tricky. So this example here shows here in the UK, which is where I'm based, or I think this is just England and Wales actually, before the UK police come after me for getting the terminology wrong, which happens. And you can see that on this map, nearly 70% of people are living just in these green areas, which is only about 6.2% of its land. Now, when you're creating maps of this sort of area, your eye is going to be initially drawn to these really big, wide open spaces, not on this map because we've highlighted the urban areas, but your eye is going to be initially drawn to those big open spaces that actually only like 30% of the people live there. So you're going to be making decisions based on a really small percentage of people. Also, just to skip back to the first point, because I like to do things back to front to keep things interesting, regular grids also make it really easy to combine data from lots of different geographies to just one grid. So if you've got data, some of your data is points, maybe it's like accident locations, some of your data is census data, comes from census blocks or output areas. Aggregating all of that to just one common geography makes it really easy to combine those data sets in conjunction. And then my final point before I talk more about spatial indexes in particular is that a lot of irregular geometries, these administrative zones that we've been talking about, can be really influenced by political design. So if you did a degree in GIS or geography, you've probably heard of the term gerrymandering, because it's one of the first things you always learn. It's all about how political parties might redraw the boundaries of administrative geographies to try and influence the result of an election. It might just not just be the result of an election, it could be to try and get more funding for something or to try and push a certain policy through. But these sorts of areas are very heavily influenced by politics. So by aggregating data to regular zones, you can sort of take the politics out of your maps, which we all want. So moving on to indexes. You probably, I assume we're all sort of mapping enthusiasts here, is kind of why we're here. You probably see loads and loads of maps that have hexagons as the main geography of them. And I don't know if you've ever wondered why, but there's some really good reasons for it. So basically hexagons are the shape that tessellates, and by tessellates I mean fits exactly together as a regular grid. The shape that tessellates that is closest in shape to a regular circle. And there's loads of benefits to having that really regular shape for spatial analysis. So it means that the distance between the centroid of that hexagon is the same distance to all neighboring centroids. It means that there's no really acute angles in that shape, so there's no real outliers in any directions like you would get with triangles, and to a lesser extent squares. It also means that with hexagons, all neighboring hexagonal cells have the same relationship to that central cell. I'm just trying to work out if I said that right. Yes, I think I did. Which means that when you're running spatial querying and joining based on spatial relationships between those cells, it's much more straightforward than with, say, squares, where you sort of have 4 that are touching and then 4 that are sort of cornering, and it gets a bit more complicated. And finally, unlike square-based grids, the geometry of hexagons are really well structured to represent curves in most of the geography that we have in the world, such as roads and rivers and boundaries, whereas square grids aren't so well equipped to deal with that, and also much better for mapping gradual changes and movement flows. So that's all sort of why hexagons are brilliant, and that's why you'll often see hexagons as a support geography for a map. And spatial index called H3, which is developed by Uber, is a really great example of employing hexagons to really master location intelligence. So H3 is probably the spatial index we're going to be really focusing on the most today, and it's one of the most commonly used, but it's by no means the only one. There are plenty of others. So the other 2 really big spatial indexes that you'll see talked about are QuadBin. So that is a square-based index, and this is where the world is basically broken up into squares, and each square subdivides into 4 squares and then 4 squares, and it runs 26 resolutions. So closest to the equator, you're looking at a resolution of about 1 meter squared up to, I think it's about 300 million kilometers or something massive. So there's a really great variety there. And then finally, S2, which I won't go into too much detail on because it's a bit less commonly used. This is a quadrilateral based index. And what's different about this is it's spherical based. So I won't go too much into coordinate systems and projections here because we don't have 6 hours and I'm not a university lecturer. But there's basically different methods of mapping the Earth, of projecting a 3D globe onto a 2D plane. QuadBin and H3, if I'm not mistaken, are based on a cylindrical form of mapping, which means that there's very little distortion around the equator, but a lot more distortion around the more extreme latitudes. Whereas S2 is based on a spherical coordinate system, which is where there's less area-based distortion around the more extreme latitudes. So if you're mapping very large regions or mapping around the North or South Pole, S2 could be a really good bet. So that's an overview of the main types of spatial index. When you've chosen your spatial index to do your analysis with, the next thing you need to do is to choose a resolution. Now, as I mentioned, these are hierarchical, so each resolution will map and fit to each other. And they range, I think H3 has about 16 resolutions and QuadBin has 26. I'm not sure about S2 because I'm less familiar with that. But the resolutions range from 1 meter squared on the ground to millions of kilometers squared. So when you're choosing a resolution, there are a couple of things you need to consider. First of all, what scale and precision your input geography is. So if you have input geography that comes at like a county level, there's no point choosing a spatial index where the resolution on the ground is like 200 meters wide, because you're just not going to get any level of detail there. And similarly, the reverse. But then secondly, and most importantly, what are the problems you're trying to solve? You know, if you're trying to work out what junctions are most dangerous in terms of road traffic accidents, you're probably going to want a really, really detailed resolution. But if you're trying to look at something more neighborhood level, for example, what's air quality like at different neighborhoods, you probably don't need that level of detail. So it's all about really thinking about the problem you're trying to solve. So let's look at some of these in action. Before I do, I think we are going to have a second poll because we love to keep these interactive. Can I ask my glamorous moderator to flash up our next poll, please? I think I need to pop back.
I can read the question.
Oh, brilliant, thank you.
Colin. Perfect. So the next poll question is, how well do you know SQL? And the answer is, 1, you consider yourself an expert, or you're quite familiar and feel comfortable using it. You could also know a little bit, but avoid using it whenever you can, or you don't know SQL at all. So I'm going to give just about 45 seconds or so.
And this poll is anonymous, so don't feel like anyone will know what you've put.
Exactly.
And it also won't preclude you from enjoying the rest of the webinar. We've got sort of SQL and low-code demos to show you, so there'll be a bit in there for everyone.
Exactly, and the answers. So the vast majority, 55%, say that you're quite familiar and feel comfortable using it. 20% consider yourselves experts. Awesome. 13% equally either avoid it whenever you can or don't know it at all. So a total of 26% for the avoiding or not knowing SQL.
Okay, fantastic. I think I probably put myself in the majority with those people there as well. So hopefully this will be pitched at the right level for the majority of you. So let's move on to the demo part of this, which is always the scary part because you never know what's going to happen with the Wi-Fi, but I think everything's going to be fine. So let's just start. I wanted to start this by, I know there's a couple of people who are here who came along to the spatial data science boot camps in the last couple of months, so they've probably seen this map. So if you want to spend 30 seconds going to get yourself a cup of coffee, then that's absolutely fine. But I just wanted to start the demo with illustrating the power of spatial indexes. Now, the power of spatial indexes is diminished by my laptop's ability to stream things well when I'm sharing my screen. But hopefully you can all see this and it's all going to go well. So spatial indexes are really, really great because they stop you having to compromise between scale, the size of the data, the sort of breadth of the data that you're looking at, and detail. And that's something that spatial data scientists and GIS analysts have been having to battle with since, you know, Jon Snow first mapped cholera in London. I feel like I should get some sort of award for managing to tie Jon Snow into this. But I wanted to illustrate that with this example. So in this example, we're looking at a data set called, or it's a human mobility data show, so it's showing average footfall across the United States at a quad bin level of 14, I think, which is about 200 meters. So each of these cells represents about 200 meters on the ground. And I just really wanted to show you how incredible spatial indexes are at giving you this amazing level of detail. Like you can pick out individual gas stations with this data, but also the entire of the United States. Something else you can probably see with this map as well is the resolution is changing as I move in and out, and that's one of the ways they're so effective is you can zoom out and get a much more broader, more regional picture, and then zoom in and the resolution increases and you can see it at a more local level. So that is just a really quick illustration of how spatial indexes, the sort of benefit of them and how they really help with that trade-off. And now let's move into an example. So first of all, I don't know how many people here are CARTO users, CARTO customers. So I'll start with a really quick, really whistle-stop tour of CARTO and the different components to it. So if you're a CARTO customer, when you sign up, this is part of what you get, the CARTO workspace. So there's a few different elements here I want to show you. First of all, your connections. So the real sort of MO of CARTO is that we want GIS to be cloud native. So with CARTO, you can connect to your cloud data warehouse. So there's plenty of different ones available. You can connect to BigQuery, Databricks, Redshift, Snowflake. You can also connect to Postgres. And also, if you are a more traditional GIS user, like your data is in shapefiles or GeoJSONs or CSVs, we also provide a small cloud data warehouse for all our customers, so you can load your data into there and use that. We also have a data observatory, which is normally the thing that is naughty when I do webinars and takes a little while to load. But this is where we have loads of different data available for our customers to use in their analysis. Some of it is premium, so it's an extra subscription, and some of it's just open data that we've collated for people. So there's data on things like demographics, human mobility, like I just showed you is in here, financial spend data, there's loads in there, about 12,000 data sets. Then we have our Data Explorer, and this is where you can explore all of the data that you're either connected to in your data warehouse or that you've subscribed to via your data observatory. And then I won't go into this in too much detail now because I'm going to show you later, but we've also recently launched CARTO Workflows in beta, which is a visual tool for processing and streamlining your analysis and creating analytical tools, and it's low code. So if you are not a SQL fan, if you are one of the, I think 12% who said they avoid it at all costs, then we have tools like this to help you streamline your analysis. But let's move to my favorite part, which is maps. So the data set that we are going to focus on today is we're going to aggregate building heights data to both a spatial index, H3, and to census block data, and sort of look at the differences in times and speeds that processing and subsequent analysis takes. So the data that we're going to be looking at is, I think that's a spoiler, that's the results. Let's look at the raw data. Forget you saw that. So this is the data that we're going to be using as our raw data. It's building height data for all of New York, the 5 boroughs of New York City, that is. So you can see it's a really big data set. I think there's about 1,500,000 rows or individual buildings in here. So you can see as we sort of pan and zoom out, now CARTO is really set up for big data because we're cloud native, but even being cloud native and being CARTO means that we're still getting these sort of, I call them empty squares of doom, where the data just can't render because it's so big. So there's a few different options here. You can convert this to a tile set, which is basically a way of rendering the data, but that means you can't run analysis with it. And then the other option is to convert this to a support geography, which you can continue to run analysis with and renders much better. So there's 2 support geographies that we're going to look at in this analysis. So first of all, we're going to look at census blocks as our sort of traditional geometry. So census blocks are, if I'm not mistaken, because my knowledge of US administrative geographies isn't as good as my knowledge of the UK, is the smallest sort of administrative geography that you get in the US. Now, this data set you can actually subscribe to for free from our data observatory, which I will just show you now. Just grab some water. So you can just search for it, or you can use these different filters. So we can say, I only want to see data sets in the US, geography data sets, so boundary data sets is what we're looking for here. Public data sets, so these are ones that you can just access for free via CARTO, and you can say it's the top one. So census block data, we can click on here to see a bit more information about it. If there were more variables and attribute data behind this, we'd see some more metadata here as well. But we can preview the data table, preview the map. And if I wasn't already subscribed to this, then there would be a button here saying subscribe, and you just have to click that, and then you have access to the data. And then you can view the subscription in here, and then click access in, and then this will give you the SQL that you need and the data table that you need to be able to run this analysis. So that's our census blocks, our traditional geometry. Now we need our H3 cells. So with H3 cells, there's 2 different ways you can create them. I'm going to show you the SQL version and the low-code version. So the SQL version, I think I have in here, is actually, I will show you where to access that first. So if you head over to carto.com, onto our documentation and go to Analytics Toolbox, this is part of the sort of CARTO package, as we provide all these analytical tools and frameworks for people to be able to run really complex spatial analysis and data science workflows. So in here, we're working in BigQuery today. So if we head down to SQL reference and H3, we can see all of the different functions that we have available to work with H3 data specifically. We've also got the same you can see for S2 and QuadBin. So we have one function here that we're going to use today is H3 polyfill, which basically you define an area. So here we've got these 5 US counties, which are the counties that make up New York City. We're going to turn those basically into a H3 layer. So this is the SQL that you would use. And you can see this is going to generate 52,000 features and about 800 kilobytes worth of data, which is really tiny. And then another option, as well as the SQL, is to do this in CARTO workflows, which is a low-code option. So here's one I created earlier. Let's just get rid of that so you can see it in action. Okay, so the first thing we need to do here is, I've said it's low code because there's occasionally bits of code that you do need to implement. So here we've just selected our 5 counties that represent New York City. And then all we need to do is find a component, which is basically a tool, SQL-based tool, but you don't need to bother with SQL, to convert that to H3. So if we go into spatial indexes down here, And we're using H3 polyfill, so it's basically the same tool as in the SQL, but it's low code. So all you need to do is connect it, select the resolution, so how detailed you want it to be. We'll just keep it as 8 for now. Click run, and this will be doing the same thing as the SQL did. You can see here now we've generated 1,060 H3 cells across New York, which we can preview on a map, and also preview the data. And here you can see we've got those reference strings that represent H3. Now I just wanted to show you something else you can do really quickly, which is convert that back to geometry. So I don't want you to think that just because you're working with spatial index, you're sort of stuck in the spatial index world. If you need to convert that back to a geometry with the sort of polygon and vertex descriptions, then you can. So if I now have a look at the data in there, you can see we've now got a geometry description. So now we have our both of our data sets. We have our H3 table and we have our census block table. We've got them here in, I'm now in the Google BigQuery console, for those of you who aren't BigQuery users. I've got them in here, so we can just take a quick look. So here is our H3. We're now, the one I created earlier is resolution 10, which is a little bit more detailed. So we can see that we have our 51,000 H3 cells, and then that is about 800 kilobytes. Whereas our geometry data, which is our census block group here, we have about 10,000 less features in here. We've got 38,000, but that's 9.37 megabytes. That's 10 times bigger in terms of storage size than our H3 cells. So the next step here, I've just got half an eye on time because I know Daria's got some really interesting stuff she wants to show you as well, is we're now going to convert this data to both our H3 cells and our census blocks. The way we can do that, again, is from our analytics toolbox. We have a module in here called data, and this has loads of what we call enrichment tools, which are all about converting data from one table and geography to another geography. We're going to be using the tools enrich grid, which enriches our H3 cells, and enrich polygons, which enriches our census blocks. So I believe I've got these SQL for this saved in here. It sounds complex, but it's actually really simple SQL. It's kind of the same in both. So you basically call the function, so enrich polygons and enrich grid. You select your input geographies. So here we've got our census block groups, and here we've got our H3 cells. Then we input our building heights data set that we're going to use to enrich, which is the same in both. And again, we say which is the field from that data set that we want to enrich our new data set with. So it's height average for both, and we want the average of both. And then we just need to specify an output table, and it's that simple. And you can see these are the differences in the output table sizes as well, which I think is really important to see. So again, the census block groups with that additional height variable added to it is still 10 times bigger than the H3 grid. But I think what's really important to think about here is that both the power of cloud native analytics is both of these took about 20 seconds to run, and that's converting 1,500,000 buildings to 30 to 50,000, whether it's census block groups or H3 cells, in about 20 seconds. So that's incredibly quick, which is just really, really useful. Speeds up your processing time so much. But obviously with H3, you have the added advantage of generally it's quicker, and generally, in fact, always the data sizes are going to be much smaller. So let's take a look at the results of those. So we've got in here H3 building heights. Now we have a table which has our H3 reference and our height average. Please don't ever name tables and data sets as badly as I do. These are all null just because they're areas without buildings, but there are values later on. And then we have building heights for the geometry as well. And you can see in here we have our building heights, and we have the geometry information and other data as well. So if we've got time, I think let's just take a look at the outputs of those. So let's head into webinar results. So let's take a look at the results of building heights first. So I hope you can already kind of see a bit of a problem that we have here. I mean, it's rendered quickly and it's rendered for the whole area, but you can see, in fact, I think that's covering it. You can see at the bottom that we've got the error message, some rows have been filtered at this zoom level. And that's because the data set is so big that it's difficult to see, it's difficult for the computer, the browser, to render all of that. As you zoom in, they start to appear, and that's just because the computer doesn't have to render everything else. One of the other problems here is that it's really difficult to see what's happening where the census blocks are smaller. So for example, you can see these really big blocks out here in, I want to say Queens, but my New York geography is not very good, and over here on Staten Island, but actually making out the detail nearer Manhattan and in sort of Midtown is much more tricky. So now let's move on to building heights for the spatial index. So one of the really good things you can do when you view spatial indexes on here in CARTO is you can change the resolution of how they render. So at the moment I've got it rendering as detailed as they can, but I can also switch this. In fact, I'll just zoom in a bit so you can see that easier. I can change the resolution so that it's more or less detailed depending on sort of the story I'm trying to tell. And if it's less detailed, then as you zoom in, hopefully you can see that you can start to see the data in more and more detail. Something I just want to quickly point out is you'll probably notice that there are some gaps in this data, and that's just because I've queried this, which I can show you here. We can use SQL querying in CARTO Builder in app to basically run analysis and iterate things, which makes it really easy. You don't always have to be running it in a different console. You can see I've eliminated any areas where there's no building height, so no buildings in the area, which is what those blank spaces are. And then one final thing before I move on and hand back to Daria is spatial indexes are also amazing for rendering in 3D. So I just wanted to really quickly show you what that looks like. So back where we changed our resolution, we can also add a height onto our data, which I've done here. So we've added a height of 20 on. And then if I just bring the opacity down a little bit, you can create these really, really stunning visualizations that if I tried to do this with a census block geometry or something else irregular like that, not only would it take ages to render, but it would just look really ugly because of how complex the geography is. Whereas the simplicity of the geography in spatial indexes means that you can do things like this and it looks really, really gorgeous. So the final thing I wanted to show you, that's gone so quickly, I could talk about spatial indexes all day. The final thing I wanted to show you before I move on is that spatial indexes also open up a whole world of analytical possibilities. And I'm just going to go for the final time back to our spatial analytics toolbox and show you this module called statistics, which is a bunch of tools that our brilliant data science team have created to help you get the most out of your spatial index data and run really great data science functions on them. So we have a bunch of different tools available in here. We have Gettysord here, which is basically a hotspot tool. So working out where there are significant clusters of high and low values in your data. We have this tool here called geographically weighted regression, which we actually have just posted a blog on. So do head over to carto.com to give that a read. It will give a much more detailed explanation than I'll be able to now. But it basically, if you've got a spatial index with multiple variables within it, it will work out the local strength of relationships between those variables. So for instance, I recently was running this based on where there are relationships between population and number of accidents, but also different types of amenities like bars and clubs and the number of accidents. So it's really, really interesting. And then we also have Morin's Eye, which I know Daria is going to talk about in a little bit more detail in a second, but this is a lot like Gettysord. It's like a hotspot tool, but it also, as well as identifying hotspots, it identifies outliers within hotspots. So if you've got loads of high values in an area, so loads of really tall buildings, one spot within that area that has really short buildings, it will pick those out so you can start to determine those patterns. And then, oh, I've got so many tabs open. I always do this when I'm doing a webinar. Just to show one of those in action. I've run Gettysord, which is the first one I showed you, the hotspot tool here. So it's a really short bit of SQL. We've just got the Gettysord function down here. And then what we're doing here is just saying we're only going to, we're filtering the data to only where we have statistically significant results. So let's view that. So hopefully you can see this on your screens. So all these sort of areas that are colored are areas which are statistically significant for having a cluster of high-rise buildings. So I don't think any surprises here. And also the more yellow it gets, the stronger that cluster is. So, you know, we've got this area around Midtown, which is, I think, is around like Empire State Building and the Rockefeller Center and all those really high-rise buildings we're familiar with in New York, and also in downtown New York as well, which is also really famously a high-rise area. So that's just an example of the type of analysis that spatial indexes unlock compared to non-regular grids. So that was a really, really quick whistle-stop tour of spatial indexes, how you can use them in CARTO, the sort of speeds and time savings and data sizes that you're looking at with them. And I think now I'm to hand over to Daria to talk through how some organizations are putting that into practice.
Perfect, exactly. Thanks, Helen. You could just share the screen. Awesome. So after that demo, thanks so much, Helen, for a super quick but really packed live demo. Let's look at what spatial indexes look like in practice. So how are organizations using spatial indexes? If we can move over to the next slide. Great. So spatial indexes are particularly popular in organizations that generate very large amounts of location data. And this location data can be anything from GPS trackers to telemetry, remote sensing, or even customer transactions. And companies from different industries are moving from traditional geometries to spatial indexes to overcome some really important operational and analytical limitations. So these challenges obviously differ depending on the underlying use case at hand. So for example, delivery and quick commerce companies need to evaluate critical KPIs such as delays and errors in their deliveries. So to understand this, they need to analyze really massive amounts of data. For example, companies in the logistics and fleet management space are constantly looking for ways to improve their routings for better delivery times and for better operational efficiency. And once again, large amounts of location data need to be taken into account. Telecoms are another great example. Spatial indexes there are used to analyze massive amounts of network performance data to generate customer usage insights. And for example, organizations tackling sustainability and climate resilience topics are also very likely to benefit from spatial indexes, especially since they will be able to provide faster and more cost-effective ways to analyze very large data sets, and especially very large raster data sets. And finally, advertising companies, as they need to locate customers and prospects for optimizing their high-value marketing campaigns. And we'll actually take a look at this last one in a little bit more detail in an example right now. So Adsmobile. Adsmobile is a great example of an advertising company that is using spatial indexes to really benefit their business. Adsmobile is a company that has presence across the US, LATAM, and Europe, and runs really massive campaigns targeting more than 600 million users. So to determine the best targeting strategy for their campaigns, Adsmobile has to analyze huge amounts of different types of data. And for example, this can be POI data, demographics, human mobility data. And moving to the next slide, Adsmobile actually turned to spatial indexes and is using spatial indexes in their analysis for several key reasons. First of all, they can analyze their data much more quickly than with standard geometries. Second of all, they, of course, because of this, get access to results much, much faster. And third, as Helen explained earlier, they also benefit from removing some of the bias that occurs when using arbitrary models, such as administrative geographies. The next example that I want to cover is Arup. Arup is a British multinational professional services company that provides various different professional services in the area of the built environment. So anything like design, engineering, architecture, or planning services. And Arup's city modeling lab team actually used an H3 grid and enriched that H3 grid with the counts of traffic accidents across all of London. And they actually used local Moran's eye, which was just mentioned by Helen at the last part of the demo, to identify these spatial outliers. So those areas of particular interest where there are locations which have a relatively high number of accidents in regions that generally have a much lower number of accidents. So those outliers. And this enabled them, their team, to actually explore factors that may be behind these really dangerous areas. So, for example, this allowed them to look at particular types of infrastructure that impact these accidents. And to summarize, by now, we hope you've seen that spatial indexes are truly the next generation of scalable location analytics. We at CARTO really think so. And using spatial analytics, your analysis really becomes much more efficient, more flexible, more objective, and ultimately more impactful. And on top of all that, you no longer have to worry about the processing, the storage, and cost constraints when approaching analysis of really, really large volumes of data. And finally, with Helen's live demo, we also hope that you've seen how easy it is to do spatial indexes, to work with spatial indexes in CARTO. So whether you're using Google BigQuery, I know we showed Google BigQuery today, but you're either using Google BigQuery or Snowflake, Redshift, or Databricks, CARTO's analytics toolbox gives you access to spatial indexes through these simple user-defined functions, or UDFs, as they're called. And these UDFs are actually available to all CARTO users and can be accessed either directly through the CARTO platform or directly through your cloud provider's console. And just a little bit of more information, if you're looking for an even more in-depth overview of spatial indexes, then please head to our report on Spatial Indexes 101. We'll be also linking that in the follow-up materials to this webinar, where you can really dive into the topic and get even more examples of how to use spatial indexes in your day-to-day job. And finally, if you're not using CARTO yet and would like to see for yourself how spatial indexes work, play around with them yourself, go to www.carto.com and simply click on that try for free button at the top, and you can get access to your free 14-day full feature trial of CARTO. And with that, I believe we are heading over to the question section. And I know we have several questions that have dropped in. Okay.
Awesome. Have I stopped sharing my screen? Can you see us now?
Yes, you're not sharing your screen anymore. And Helen, I'll be reading these questions out.
Okay, awesome.
So let me know when we're ready to start. Okay. The first question is, what is the difference between a tile set and a spatial index?
That's really Yeah, absolutely. So difference between tile set and a spatial index, they're quite similar, and there are areas where they can be used in conjunction. So a spatial data set is basically still a data set, and a tile set is almost more like an image and a way of rendering data. So a tile set is where you have loads and loads of data, and it's really difficult to visualize. So you convert it from a data set from a table into a tile set, and that tile set is basically a way of breaking the data around into chunks. So your mapping platform only has to render what it is that you're looking at on your screen. So in that way, it's a little bit like spatial indexes, and spatial indexes can actually be used to optimize tile sets. But the way that spatial indexes is different is you still have that data there. So if you wanted to go and do, for example, hotspot analysis, like we showed you here, you wouldn't be able to do that with tile sets because it's not really data anymore. It's a way of rendering it. Whereas spatial indexes, that's still a table. You still put all the values in there, so you can still use it for analysis. So tile sets for rendering and visualization, and spatial indexes for that, but also analysis.
Okay, awesome. The next question. In the census tract example, is the index value the ID of the smallest cell that the spatial object fits within? This is John's question from the beginning of the webinar.
In the census tract example, is the index value the ID of the smallest cell? So I think I understand the question, which is that with the census tract, it comes with an ID. That's not anything to do with spatial indexes. It's basically every administrative geography in the US comes with an ID associated with it. And that ID basically says, I come from this state and I'm in this census tract, I'm in this census block group, and I'm in this census block. Oh, I mean the index value of the H3 grid. So every H3 grid is basically, is the index value of the ID the smallest cell spatial? No, not really. It's just basically a descriptive string. So it's a series of 14 characters or however many it is that just places it in the world.
Awesome, thanks so much.
Thank you.
Stefan also asks, why did we switch to BigQuery to look at the tables in detail?
That's a good question. It could just, the answer is generally personal preference. I find it easier to visualize tables in BigQuery. If you want to visualize them in CARTO, it's a little bit more tricky because it's so set up for mapping. So if you run a query in CARTO in the console, then you can add something called a widget to your map, which is like a dynamic graphic asset. So we have like bar charts and histograms like that, and one of those is a table, so you can visualize a table in that way. But if you want to look at the actual tabular data, BigQuery is just a bit more set up for that than CARTO, which is more for mapping the tables. Hope that makes sense.
Thanks so much. Okay, another question about using H3. If I'm using H3, how can I do spatial join between my points across a whole country and hex in resolution 14, for example?
Yeah, exactly. That's a really good question. So those enrichment tools that I was running through earlier is a really great way to do that. So you would need to generate a hex grid. So you would use the H3 polyfill function that I showed you to say, if your country is the United States, you would find a boundary for the United States. You might use something like Natural Earth that we have in CARTO to say, I want to fill that country with H3 cells at resolution 14, and then you could input that query into the enrichment function, and then you would say, I want to enrich that with my points data and run it that way.
Awesome, thanks so much. And a question is, H3 the only spatial index available in CARTO? Do you support plus codes? Is this a configurable option? If so, are there tools to re-index data? Well, several questions there. Maybe starting with the first one, is H3 the only spatial index available in CARTO?
No, H3 is not the only spatial index available in CARTO. So I would say H3 and QuadBin, which is a sort of square spatial index, are the two that we support the most fully. We also support S2, but to a slightly lesser extent, so it has slightly fewer functions. I can't find what was plus codes. I don't believe we currently support plus codes. I haven't come across that. I will do a bit of research on it and see what that is, because that sounds really interesting. It's the kind of thing where if enough people, enough of our customers are really interested in that and it's really useful to them, then that's definitely something we could explore.
Awesome. Thanks so much. I believe we do still have time for 2 or 3 more questions. There's a lot coming in. So thanks so much for being so active on this webinar. Really appreciate that. Another question is, I am curious to know the spatial resolution of the H3 grid versus the census blocks used in the example. Are H3 coarser, hence the smaller size after enrichment?
That is a really good question. It will be different in different places. So one of the problems with census blocks or census tracts or any geography that's like that, that's an administrative geography, is they vary so much in size. So it might be in some cases, the H3 cell is more detailed. So for example, if you've got a census block that is around, I don't know, JFK Airport, where very few people live there, so the census block is huge, the H3 cells are going to be smaller. Whereas if you are somewhere like Manhattan, where the population density is really, really dense, so the census blocks are a lot smaller, the H3 cells are probably going to be a bit bigger. It obviously depends on the resolution that you choose, but it generally will sort of vary, and that's one of the things you have to think about at the start, is what is the right resolution for my input data and what I'm trying to achieve.
And Alfonso asks, of all the workflows you showed today, are all the features available in the open CARTO version? I'd like to do some tests in open data.
So if we're talking about the CARTO's 14-day trial, then yes, absolutely. So with CARTO's 14-day trial, you get access to all of CARTO features. With regards to open data, so our spatial data catalog that I showed you that has about 12,000 data sets in it, I'd say probably about, I'm really estimating this, so don't quote me on it, but probably about half of that data is open data. So it's basically data that we've taken from censuses or mapping authorities or whoever, and put them in our spatial data catalog, so it's easier for our customers to use and they don't have to load it into their cloud data warehouse every time. So there's probably about 6,000-7,000 open data sets in there that you can use. So yes, absolutely, with the demo data, everything that I showed you today, you can do with the CARTO free trial.
Thanks. Can you talk about applications for spatial interpolations once the data is spatially indexed?
Oh, interesting. Yeah, I think so spatial interpolation is where you have, say, a grid, say spatial indexes, and you might have a couple of indexes with missing values in them. So that with the use case I was showing today, that's not really a problem, because if there's missing values, that's fine, because it means there's no buildings in there, but it could be that you had missing data in them that you want to maybe model what that value would be. So there's loads of tools that you can use to do interpolation in that instance. I'd say H3 or Quadbin, whatever you're using, actually makes that loads easier than traditional geometries, because you can do things with H3, like you can say, I want to set a ring around my H3 cells of a step of one group of hexagons and then a step of two or whatever. And you can use that to say, and then the average or the weighted average, I can use that to interpolate what that missing value is. And that is going to be so much quicker than if you're working with geometries. I remember when I joined CARTO and I didn't know much about spatial indexes, and I was trying to calculate, I think, the population within 5 miles of every H3 cell in Los Angeles, and I was running it overnight, and it was taking ages, and then someone was messaging me like, have you heard of spatial indexes? And it took like 8 minutes to do this huge calculation. So is a really great framework for doing that interpolation, because what can be a really slow, clunky process can be done so much more quickly and so much more iteratively, which I think is really important. With interpolation, you often have to play around and try this parameter and that parameter, and if that's a process that's taking you hours, then you're really taking a long time. But if it's taking you minutes, then you can go get a coffee and come back and then try it again.
Awesome. Helen, do we have time for one more?
Let's do one more for sure. And then let's flash up our contact details so people can message us directly if they have any more.
Exactly. And we can also answer the questions that we didn't get to, because there are several we will not get to today, but we'll make sure to answer them via email, if that's okay. And I'm sorry, just lost it here. Can we combine these spatial indexes with raster files we have?
Yes, absolutely. So I don't know actually too much about this, because it's a very new feature in CARTO, and I think part of it is beta. But if you go onto our blog, and maybe we can send it out with the follow-up email, we've recently released a new toolbox for importing raster into cloud data warehouses, and spatial indexes aren't the only way, but they're a really great way of sort of supporting that migration of raster data, which traditionally isn't something that you could really use in data warehouses. You had to use vector data, but spatial indexes are really supporting that. So we'll definitely share that blog post so you can see how that works.
Thanks so much for joining today's webinar. Thank you, Helen.
Thank you.